Hey, good afternoon, everyone, and welcome to this week's Wednesday version of the Data Ravens channel on YouTube. Today, we're going to talk about pandas and Python. I apologize. We had a little bit of technical difficulty yesterday, but we're going to catch back up today and be ready to go for tomorrow. So today, we're going to talk about pandas. Again, love Python. It has all the animal names. And today, we're going to talk specifically about the program called Pandas. So we're going to talk really about basics, and then we're going to step it up just a little bit. But Pandas is basically one of those basic programs that you have to learn. And if you're going to work in Python, it's definitely something. There's lots of functionality that we're not going to cover today. We're really just going to cover the brief overview. And basically, if we take everything back to our framework here. What we're really talking about here, we're going to be working down here again in this lower left. In the coming weeks, we'll continue to work up this continuum and get into some various things. But for the most part today, we're really just going to be covering how to read in the data from a transactional standpoint and some really basic descriptive statistics. So the business problem that we're working with here is that you have some data that you want to work and manipulate with, or you want to manipulate it. So you're going to learn to work with data. Pandas is just one of the many larger programs that we'll cover as part of our training here. But that's really the business problem that we're trying to solve. You have some body of data that you want to work with and you want to manipulate. And again, it's Pandas is a powerful, flexible, very fast, and easy to use open source data analysis and manipulation tool. It's built on top of the Python programming language. So again, you'll see the functionality that's built in with one of these add-on packages. So let's get into it. So I'm going to close this. If we go into, so what I did was, again, I'm having some memory issues with my computer. But what I did was I went ahead and imported the programs already so that we won't have to wait for that as we're going through. So you can see there's already a number there. So what we're going to do here is there's two programs we're actually going to import because they work with one another quite often. One is called NumPy, and you'll see there it's NUMPY. And what you'll notice here is we could actually import both of these packages and just say import NumPy and import Pandas. Instead, we give it a little shortcut. And you'll see here, for example, you'll see this a lot down below here. It says import Pandas as PD. Well, PD is the shortcut name. It's a standard shortcut that people use, though I'm sure other people have. Some people might call it PA, whatever. I learned you basically use PD. And what you're doing is down here where it says below, you're replacing the word pandas with PD. So that's what you're telling it. Import pandas as PD. So the first thing we're going to do here is we're going to read in a series. We're going to use, so PD is the, again, pandas, and .series is the pandas command, if you will. And that's what we're reading in here. So we're saying S is a series that consists of 1, 3, 5, NP, NaN, which is a null value or a no value, 6 and 8. And then when we type S, what actually happens is, so a lot of times what you'll do is, like, if I take this out of here and I run this, you'll see it executes pretty quickly, but we don't know what's in S. So a lot of times if we just put S here again, now you'll notice when I run this again, this is going to turn into a 3. So that's how you can keep track of the cells that you've actually run. And now it's actually going to give an output. It's going to say the output of 3 of the following numbers. And it's a series, and it's a float 64, which is just, it's basically a floating decimal. The other thing that you might notice is that I have 6 numbers here, six items in the series, 1, 2, 3, 4, 5, 6. But in Pandas and in Python, your first element always starts out with a 0. So when we get in later on into some of the iLocation commands, you'll always notice that this is not actually value number 1, it's value number 0. Here's an example where I'm going to create a little series called dates. It's going to be used the command called date range. it's going to start with this date here, and it's going to go out 6 period. And again, when I type the word dates here, I'm just saying I want to see it after I create it. So I'll go ahead and run it. And you can see here, this gives me a series or a table of these items, time periods, again, starting with the 1st of 2013, going for 6 periods. The next one here is I'm going to say, let me use this term data frame. Now, a lot of times you can work with series or data frames. A lot of times we'll work with data frames. And this is going to create a data frame. It's going to create using a random number. Again, this is the NumPy random number command. So you can see cell. And then it's going to create also columns in there called A, B, C, D. So when I run this, now it lists, here's my data frame, very typical, very similar to an Excel workbook, but that's basically what it is now. So now all these items that I've created continue to be in memory. So I've already created a DF. Now if I go down here, my next one, I'm going to be a little bit more structured here. If I accidentally called this DF, it would replace whatever I created initially in the DF up here, but I'm purposely calling it DF number 2. So when I do that, I'm telling it I'm going to have a data frame with column A through F, and I'm doing a variety of things here. In column B, I'm using a timestamp. In column C, I'm using a series with an index of range 4, and I want it to be a float 32. In column D, I'm using a NumPy array. In column E, I'm creating categories for test, train. And column F is going to all be the word FOO or foo. So I'm going to go ahead and run this. And again, now I create four rows and 6 columns. And there's my new data frame called data frame 2. Another command that I can use in Pandas is dtypes, and that stands for data types. So when I run this, it's going to tell me, okay, column A is float 64, column B is a date time, column C is float 32, column D is an integer, column E is a category, and column F is an object. The other thing that I can do is now in this particular one, if you go back to our data frame up here, this particular data frame again was only 6 rows. But if I want to do, if I want to look at the header, just the heading of that, and this is useful for, let's say you read in a large data frame with 100 rows or 1,000 rows or 10,000 rows or 1,000,000 rows. This is just useful to get a feeling to see how did it read in, especially if I'm bringing in a CSV file or an Excel file. You can use this DFHead. That's pretty typical when you're doing early on after you've read in the data for the first time. So when I run that, it's going to just give me the first 5 by default. Now notice, and then the DF tail will give me now here in the parentheses, I put 3. So I'm telling it, let me see the last 3. I could also do up here, I could do 2. And it'll give me just 2. But again, just remember that you're just using that to get some idea of how did it actually read in. Especially more helpful when you have different column names that might be different words or whatever. That's why it's useful to use the DF head and the DF tail. And, because again, if it's 100 lines long, it's going to list them all and you'll have to actually scroll through it. And that's not really going to help you at that point. Another data description or data frame description tool is DFShape. So when you run that, it's going to tell you that, again, I have 6 columns and I'm sorry, 6 rows and 4 columns. So it's always rows and columns. So if we go back up and look at it here, here's DF. Again, 1, 2, 3, 4, 5, 6 rows and 4 columns. 1, 2, 3, 4. Again, they're numbered 0 through 5 from a location standpoint and 0 through 4 for the columns. Again, just gives you some idea. If you know, for example, that you're reading in an Excel spreadsheet or a CSV and it's 30 columns by 10,000 rows, it's just useful to validate that you know it. And then the last thing that I'll show you here from a description standpoint is what we call DataFrame Describe. So what that will do is for the items that are numbers, it will give you the descriptive statistics for those columns. So here again, it counted 6 values in each column: the mean, the standard deviation, the minimum, the 25, 50th, and 75 percentile, and then the maximum. Again, useful just early on in your exploratory data analysis to get some idea of what you're dealing with and what you should be able to see. Another thing that you would normally start doing at this point, and we'll get into this at some point, is how to do, for example, some charts, some box plots or a histogram to get some idea of what the data and it looks like and what the distributions are. Another useful tool would be to transpose the data. So if you want to flip the columns and the rows, you can run that, and now all of a sudden you can see my columns have become my rows and my rows have become my columns. The other thing you could do is here's a data frame, a Panda command, sort values, and you're telling it that you want to. Now notice one thing before I go on, I didn't create a new data frame here. I just said DFT, and it showed me what that looked like. It didn't change the data frame. In fact, if I go back, if I was to insert a column, a cell here, and I type DF, I'm going to get the original DF. Now, if I had come in here and said, and I'm going to call this something I know I haven't created in, I'm going to just call this DF10 equals and run this. And now if I came in here and said DF10, I've created a new data frame called DF10. Now, where you need to be careful is if you accidentally called this DF, later on you might go back looking for the DF and it would actually have changed it. So remember, if I just use this command, if I just want to look at and see what it would look like transposed, I don't have to create the data frame. I could just say data frame transpose. Here I'm going to go in and I'm going to sort by the values. In this case, I'm going to use column B. So when I do that, again, it's not creating a new data frame. It's just showing me what that looks like sorted. Another thing that I could do is I could say, hey, I just want to see column A. And it will show me here's column A. Now, again, this is useful for whenever I'm working. I may want to actually extract a column and create a new data frame with that. So that's where I find this. Here, next thing is some of the stats. So here's one where I just want to do a mean. And again, when I run this, it's going to give me the mean of each column. Okay, so let's do some really brief plotting just to show you, again, what some of the capabilities are. I'm going to bring in another program called Matplot Library, PyPlot. And again, I'm going to make this shortcut as PLT. And then I'm going to create a time series, again, using the Panda command series. I'm going to use a random number using an index of a date range for 1,000 periods. So basically, I'm going to go in starting on 1/1/2000, and I'm going to create a time series with this characteristics here. One of the things I could do here is a cumulative sum. So when I hit this, and then when I plot it, so then when I plot it, you can see very simply I created going out 1,000 periods using this as the date range, and it creates a very simple plot by using this series command. The next thing I want to do is, for example, I can then come out here and I can pull in another program called Open Pixel or PyXL, and it's a tool that just is used to work with Excel. And when I do that, I'm going to write my data frame that I created. Again, my data frame up here that I created. I'm going to go ahead and this one here, DF, which is still known as DF. And I'm going to go ahead and create and run this. And when I do, it's going to export that to a data frame. Now, this would essentially also be useful for when you're creating outputs that you need to send to other people that may not be able to work in Python or R. This is useful when you can actually do that. So we'll show this here. I'll do this real quick, and when I run this, it'll take a little bit longer because it's going to pull in that file, and then it's also going to create the output file, and I'll show you where that goes. So if I flip over to here, you'll see this is the working directory, and it created this folder in here, this file in here called foo xlsx. And if I go back now, just as an experiment, if I want to read this in, so again, let me open this up real quick, so you can get it. You can see what it actually looks like. So here you go. If we go back and we remember our data frame again, the 6 rows and the 4 columns, and it's exactly what we exported. So then another trick here is I'll pull that Excel back in and create a new data frame, just so not to confuse it with the original one. And again, when I do that now, this is another data frame that's sitting in the Python memory. We'll do some boosting here, boosting of your boosting of your Panda skills. So these are some things that are kind of a step up here. This is one here where I'm going to create 2 sets of random values. I'm going to use the years, and I'm going to arrange them. I'm going to create these groups, and then I'm going to create this data frame using all this information up here. And I'm going to do all this, and then I'm going to type it out again so I can see what that data frame looks like. So this is what it looks like here. It's basically 10 rows, 4 columns, and 0 through 9. And then what I'm doing here is I'm going to use, so for example, if I want to use, again, a Panda command called query, I put the data frame first, then the word query. And what I'm telling it is, hey, I want to do anywhere where value 1 is less than value 2. And when I do that, again, 2, 3, and 9 are going to come out. And again, I could create it at this point. I could create another data frame. I could come up here and put, for example, data frame 11 equals, or again, you might just want to do this on the spot. Another thing I could do is, let's say I want to create a new column. So I'm going to create a bunch of values here I'm going to call it new column. And then I'm going to go ahead and I'm going to run this. And when I do, I've now created a series of values called 10 values called new column. Then I'm going to say I want to go ahead and put that into data frame 5. Now, this particular command will actually change the data frame. And when I do an insert, just much like in SQL, when I do it, and now when I run this again, we'll see here now I have a new column. So up above here, I didn't have it. Now I've gone ahead and inserted it. Another thing I can do is, again, the cumulative sum. So I could do this, and then when I run it, it'll actually add. This is another one that adds to the data frame. So it adds a cumulative summation column to it. And again, it said based on value 2, that's how I want to group by. So you'll see here what it did. It did 0 plus 8 is 8. And then it started over again with a different group. But they're basically, again, just showing you the functionality and how you can manipulate the data frames. The last one I'm going to show you today is the sample. So the sample would be, okay, I want to pull a sample from the data frame, and I want to pull three samples out of my 10 rows. So when I do that, it's going to, again, it picks them at random, and it gives you the ability to, again, pull a sample. And again, you can see how this would be useful for much larger data frames. I did put in here also, and this will also be posted up to my GitHub page, and we will be covering GitHub on Friday's video, on tomorrow's video, and how to use GitHub to get and see what other people are working on. It's basically a repository for code used a lot for Python and for R. But this will actually be posted up there. And then if you go down and pull this down onto your computer, you'll be able to go to some of these sites here and check out more about Panda. Again, thank you for joining us. And if you like these videos, please like the video and subscribe to our channel. Thanks, and we'll talk to you tomorrow.